Hi, today I'm going to jump ahead and do lesson 6-2, inverse functions and inverse relations. I haven't done this in class, but I'm going to do it now. Okay, inverses. Inverses, um, I know sometimes they say these are inverses. But we are going to talk about functions and relations, and the way you know an inverse function is like this, with this little -1 up as an exponent by the f. This is the function, this is f of x, this is an inverse. Now, inverse relations, remember functions have a one-to-one relationship that the x's don't repeat, your domains don't repeat. But relations, you could do, these are your x, y, and then you reverse them. This is now your x and this is now your y. We're going to go through all of it today. Okay, so inverse functions, we have, this is your f of x. They're telling you this is the inverse, and we'll figure out how to get those today, how to find what the inverse is. But evaluate f of 7. This is my f of x, so it is 2. But evaluate the inverse. Pay attention, that little -1 of 2, that's not f. This is the inverse function. You put in 2 and you get 7. Not all functions have an inverse function. I don't want to do the horizontal line test. Da, 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 da. Okay, let's go on. So I'll have to tell you in class exactly what that statement means. I only have so many more videos, and so I'm going on because the main part of this is finding the inverse function. And so here this is. Okay, so here is a triangle with these 3 vertices. And if we do the inverse, this is the original. Do the inverse, so instead of 2, 4, our next one's going to be 4, 2. Instead of -3, 2, our other point's going to be 2, -3. And instead of 4, 1, we're going to have 1, 4. You just switch the x and y. So I go to 4, 2, 1, 2, 3, 4, 1, 2, 2, -3, 1, 2, 3, and 1, 4. Here's the inverse relation. It is not a function because we got duplicate lines going there. Only one of them at a time would be a function. But you just switch your x and y values. Okay? Inverse relations, pretty easy. Horizontal line tests, they're talking about one-to-one. Sorry, I'm talking out loud. Okay, find the inverse, exchange the coordinates. Well, we got to find the coordinates first. So this one is 1, 2, 3, 4, 1. Is this the same one as before? 2, 1, 2, 3, 4. Oh, this is the same. This is where they actually had you do it. I need to pay attention when it says continued on next page. This is what I just did on the other page. Here we go. Here's the meat and potatoes of this lesson. So this is important. Inverses. If a function is the inverse of f of x, the graph of the inverse will be a reflection, and you all know what reflections are, but not on a horizontal not on a vertical, but on a diagonal, y equals x. So y equals x is this line right here. That is what it is rotating on. That is what it is reflecting on, not rotating. That's what it's reflecting on. Okay? So when we graph these, you're going to have one and then you're going to reflect on that axis, the y equals x. Okay, so there are three steps, and I always write these out, so I'm going to write them. I'm not going to highlight. Number one, rewrite with y. So here's our function. Great. Rewrite it y equals. So we could say y equals. Step two, switch x and y. So everywhere there's a y, I'm going to put an x. Everywhere there's an x, I'm going to put a y. Step three, solve for y. This is the same thing they said. They said exchange, but these are the same three steps. You learn these three steps, you memorize these three steps, you could find the inverse. Okay? So now I'm going to switch for y. So I'm going to subtract 2, which they did, minus 2, and then divide by 3, divide by 3. So my new y is x minus 2 over 3. I'm going to kind of write it, kind of switch like that. Okay? Which is 1/3 times x minus 2. 2. That's the same thing, same function. Okay, so here is the original. And see how it reflected across, this is the diagonal. It reflected across that. And so it's not really vertical or horizontal, it reflects on the diagonal. Okay? Replace y. Oh, they want you to put back into function notation, which is just f of x equals that. Oh, but not f of x. You got to put that it's the inverse of that. Okay, let's do the check. So remember your three steps. 1, write y equals, that's step 1. Step 2, switch x and y. Step 3, solve for y. So I'm going to come over here to the left a little and solve for step 3 and rewrite it. X equals -1/2 y plus 1, subtract 1. X minus 1 equals -1/2 y multiplied by -2. -2x plus 2 equals y. Now you rewrite it with the little inverse -1, so it's -2x plus 2. Let's graph them both over here. So I'm going to use blue for the original. So this is 1. My slope is down 1, right 2. Down 1, right 2. Up 1, left 2. Here's my original. Oops, sorry, I didn't go through my dots. This is my new function, my inverse. So I'm going to go 2, down 2, right 1, down 2, right 1, down 2, right 1. I went through all the dots. Those reflected around this axis. Okay? No, I did it right. Okay, I've done that in both these couple videos. I'm sorry. I did it right. This reflects that way. This bottom part's up here and this top part's down here. Okay. Here we have some with restricted domains, x squared. Yeah, you have one. So here's part B. See the graphs. Pretty interesting. So our first step, set y equals. Second step, switch x and y. I think I've told you in class, this is x squared. This is y squared. If we were to switch them, you see it in this graph. So then you're going to get a square root, and that's where it's restricting stuff. So you minus 4, you get this. We're going to complete the square by adding 1 to both sides. This just becomes this. This becomes y plus 1 squared. Take the square root of both sides. You get this. Now, subtract 1, but with a radical symbol, we like writing that negative 1 over here. Okay, so this is our y, so this is our inverse. We like writing it first instead of writing it after the radical. Here they are. There are some restrictions because you can't take a square root of a negative. And so that's what they are saying. When you graph these, and in the calculator, you have to do the positive and then you have to do the negative. And there they are. Okay, there's two parts to that. Okay, let's do this one. If you are in chemistry or take chemistry in college, this is a good one. You use this quite a bit. T of x equals that. For the Fahrenheit to degrees Celsius is this formula. Find the inverse. So we change that to y, switch x and y, and then solve for y. So what they did here was multiply by 9/5 to get rid of that fraction. So you get that. You get y minus 32. So you just add 32 to get y. So your inverse function is 9. You could write it like this, 9/5 x plus 32. Okay, so you could convert Celsius back to Fahrenheit using this, or Fahrenheit to Celsius with that. All right, your assignment for 6-2 is verifying. So composition of functions is on page 310. And for your inverses, you should get the same thing both times if you put g of f or f of g for inverse functions. I'm not going to do those. Your assignment is just here, example 2 and 3, page 311. And you are doing numbers 5 through 14. Okay? Thank you. Let me know if you have questions.